Good morning, class. We are looking at Analytic Trigonometry, Chapter 7, Sum and Difference Formulas. Sum and Difference Formulas. So we covered trigonometric equations and identities, and now sum and difference formulas. We are going to use sum and difference formulas to find exact values, to establish identities, use sum and difference formulas involving inverse trigonometric functions, and solve trigonometric equations linear in sine and cosine. Again, fundamental identities are being reminded. Odd and even function, being reminded periodic functions. Fundamental identities such as Pythagorean identities, quotient identities, reciprocal identities. These are the identities we have seen before, we have established, and we are going to move on to more identities. So here's the summary of this section. Sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta. Sine of alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. And cosine of alpha minus beta is cosine alpha cosine beta plus sine alpha sine beta. Tan of alpha plus beta is tan alpha plus tan beta over 1 minus tan alpha tan beta. And tan of alpha minus beta is tan alpha minus tan beta over 1 plus tan alpha tan beta. So those are the identities we're going to look at. So let's get started with the proof for them, starting with the cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta, and cosine alpha minus beta is cosine of alpha cosine of beta plus sine alpha sine beta. So we are going to look at the proof right here. And we are going to look at cosine of alpha minus beta first. We're going to look at the proof of that. To do this, we are going to consider the following angles, alpha and beta. So here's the big one, alpha. Here's the smaller one, beta. And right here, this one would be alpha minus beta. Now, we use beta such that in both cases, the initial side is along the x-axis. So we have the coordinates here, 1, 0. We have the coordinates here, cosine beta, sine beta. We have the coordinates here, cosine alpha, sine alpha. If we choose alpha minus beta such that its initial side is along the x-axis, so that its initial side at this point has coordinates 1, 0, what happens is that these two distances are identical because the central angle in both cases is identical, all alpha minus beta. So this distance is the same as this distance. So we're going to say distance from point A to point P sub 3 is the same as the distance from P1 to P2. And all we have to do, use the distance formula, and everybody remembers the distance formula. That's the distance formula. It makes it easier. Let me just write it here. Right? Everybody remembers that? So let's look at this distance. According to this formula, x up to cosine of alpha minus cosine of beta cosine of alpha minus beta minus 1 squared. This one, sine of alpha minus beta minus 0 quantity squared. That's under the radical. Okay. For this one, for this one, cosine alpha minus cosine beta quantity squared plus sine alpha minus sine beta quantity squared under the radical. So that's the distance here. Very straightforward, I hope. Let's look at this distance. Cosine of alpha minus beta minus 1 quantity squared plus sine of alpha minus beta minus 0 quantity squared under the radical. So this is this distance. Now let's set them equal. Of course, it's easier to take it out of the radical. In other words, square both sides. So what's inside here and what's inside here, they're identical. Now it's all about algebra, everybody. So we're going to square this. Cosine squared alpha minus 2 cosine alpha cosine beta plus cosine squared beta. This one, sine squared alpha minus 2 sine alpha sine beta plus sine squared beta. This one cosine squared of alpha minus beta minus 2 cosine of alpha minus beta plus 1. This one, sine squared of alpha minus beta and squared, because this basically is nothing, right? So just square this one, that's all. Just square this one, this goes away. This is this part, okay? This is the rest of it. This is this part. All right. I'm going to erase the mess so we can continue. All right. Notice cosine squared and sine squared, both of them of alpha. So that creates 1. Notice cosine squared beta, sine squared beta. That creates 1, right? So we are going to write cosine squared of alpha plus sine squared of alpha next to each other. We're going to write cosine squared of beta and sine squared of beta next to each other. And then we have this and this. If I take the -2 out, this becomes cosine alpha, cosine beta, and this becomes sine alpha, sine beta. So notice we put those two together, those two together. On the right side, we put this one and this one together because they add up to 1. So cosine squared of alpha minus beta and sine squared of alpha minus, and this one is -2 cosine alpha minus beta, and we have a 1 here. So what happens now? This is 1. This is 1. This is 1. So on the left side, everybody, we have 1 and 1. 2 minus 2 times the parenthesis cosine alpha, cosine beta plus sine alpha, sine beta. What do we have on the right side? 1 and 1 add up to 2 minus 2 cosine of alpha minus beta. And so clearly, numbers 2 and 2 cancel each other. We can divide both sides by -2. They cancel each other. And believe it or not, this is the left side, this is the right side, and that's the proof. Cosine of alpha minus beta is cosine alpha, cosine beta, plus sine alpha, sine beta. And that's the proof, everybody. What about cosine of alpha plus beta? Well, we can write cosine of alpha minus negative beta, which means in this formula, wherever we see beta, we replace it with negative beta. So cosine of alpha minus negative beta, because remember, you can think of it as x, okay, any variable of your choice. So this becomes cosine alpha, this becomes cosine of negative beta. This remains the same sine of alpha, sine of negative beta, okay? As you know, cosine of minus beta is the same as cosine of beta because it's an even function. Sine of minus beta becomes minus sine beta, and times plus sine alpha becomes negative here. So this doesn't change as a positive sign. And that's the proof of cosine of alpha plus beta. So just, I wanted you to be exposed to the proof, although you're not responsible for the proof, but it helps if you can follow that. So now we can find things like cosine of 7 pi over 12, the exact answer. And if it makes it easier sometime to, add them up in the format of degrees, you can change it to degrees. It may be easier to see what common arcs add up. So notice this is 3 pi over 12 and 4 pi over 12. 3 pi over 12 is pi over 4. 4 pi over 12 is pi over 3, meaning we really want 2 common arcs, and it may not be easy to see from here to here. Cut it in this format. Now, according to this formula now, this is cosine of pi over 4, cosine of pi over 3, right? Cosine alpha, cosine beta, minus sine of pi over 4, sine of pi over 3, sine alpha, sine beta. So following this formula, this is what we get. And all we have to do, plug in cosine of pi over 4 is square root of 2 over 2. Cosine of pi over 3 is 1/2, minus sine of pi over 4 is the same as cosine of pi over 4, which is square root of 2 over 2. This is square root of 3 over 2. So notice each one has the same denominator 4. This is square root of 2. This is square root of 6. So square root of 2 minus square root of 6 over 4 is the precise answer, everybody. We want to find cosine of 15 degrees. I think it's easy to see it's cosine of 45 minus 30. So we're going to use this formula. Cosine alpha cosine beta plus sine alpha sine beta. That means cosine of 45 cosine of 30 plus sine of 45 sine of 30. Again, all of them common arcs. This is square root of 2 over 2. This is square root of 3 over 2. This is square root of 2 over 2. And this is 1/2. Again, this has a denominator 4. This has the same denominator 4. These two, the product square root of 6. This one is square root of 2. So plus sign. And that's the final answer. By the way, as far as the arcs are concerned in the form of degrees or radians, it's really a good idea to know pi over 12 is 15 degrees. In the future, when you come across multiples of pi over 12, that means multiples of 15 degrees. So that's helpful, everybody. Again, the assumption is all the common arcs that have been discussed, we have memorized them, everybody. It is extremely important to be comfortable with those. Having said that, and you know the sum and difference formulas for the cosine, the sum and difference formulas for the sine would be sine of alpha plus beta is sine alpha cosine beta plus cosine alpha sine beta, and sine of alpha minus beta is sine alpha cosine beta minus cosine alpha sine beta. But let's look at a couple of things. We first want to prove this. We want to prove cosine of power 2 minus theta equals sine theta. Sine of power 2 minus theta is cosine theta. You may remember when we looked at the graphs, it showed it. And so one way is to graph it. Okay, so if we graph this one, and then we graph this one, it just shows you one graph, doesn't show you two different graphs. You know this is a sine graph. So graphically, with a graphing calculator, you can show that. Let us show it analytically. So I'm going to look at the first one, cosine of pi over 2 minus theta. We're going to look at the proof of that. And I'm going to use this formula. Cosine of alpha minus beta is cosine alpha cosine beta. That means cosine of pi over 2 cosine theta plus sine alpha sine beta, sine of pi over 2 sine theta, according to this formula, everybody. And everybody knows cosine of pi over 2 is 0, sine of pi over 2 is 1, and that's the proof that cosine of pi over 2 minus theta is sine theta. So that's the first identity. Now, if we choose pi over 2 minus theta to be something, for example, x, cosine of pi over 2 minus theta, if I write it as pi over 2 minus pi over 2 minus theta, everybody knows that if I apply the negative, these two cancel each other, this becomes plus theta. So this is cosine of theta, okay? But why am I writing it in this fashion? And I'm going to call this x. Then it's sine of theta, right? If you look at this formula, it's sine of theta, which means sine of power 2 minus theta. So take a look at, if this is x, think of cosine of power 2 minus x. Let me just write it in fact. Cosine of power 2 minus x is equal to sine x according to this formula. Now, if you choose x to be power 2 minus theta, you write this. Now, this one, as I said, power 2 minus power 2 plus theta is cosine of theta. So if this is cosine theta, what did we prove? The second one. We proved the second identity. So we want to prove the sum and difference formulas for the sine function, and we are going to use what we just established. So I want to go with sine of alpha plus beta, and I'm going to use this. I want sine of theta is cosine of power 2 minus theta. What if I let theta or x represent alpha plus beta? Okay, so you let this alpha plus beta be x, and according to this formula, look at this formula, power 2 minus theta is sine theta. So sine of x, sine x is cosine of power 2 minus x according to this formula we established. Now we're going to expand the right side. How do we expand it? We write it in this fashion, power 2 minus alpha minus beta. We rewrite it in this fashion. And now cosine of this minus that. In other words, now we are going to use this identity, cosine of alpha minus beta. Think about this whole thing as one angle, minus beta. So we're going to expand it using this formula, everybody. So cosine of alpha cosine beta becomes cosine of this mess, x, or power 2 minus alpha, cosine of beta, plus sine of alpha sine of beta, sine of x. Let me just put the x up here. So this is x. Sine of x or power 2 minus alpha sine of beta. So let me write this one as cosine x cosine beta plus sine x sine beta. That's it. Now we are going to continue on that thoughts. Cosine of power 2 minus alpha. Look at this one. Cosine of power 2 minus theta is sine theta. So this is sine alpha. Sine of power 2 minus theta is cosine theta. So sine of power 2 minus alpha is cosine alpha. Okay. Very straightforward. And to prove sine of alpha minus beta, we're going to write sine of alpha plus minus beta, which means into this formula, we replace the beta with negative beta. We've established it for sine of alpha plus whatever. So plus this. So sine alpha cosine minus beta plus cosine alpha sine of minus beta. As you can see, cosine of minus beta is the same as cosine of beta. So that doesn't change. but this one is minus sine beta, and we proved this identity. Now let's find sine of 19 pi over 12. And remember, pi over 12 is 15 degrees, so 19 pi over 12 is multiple of that. And so we want to cut it into pieces such that it becomes common arcs. So we can write it as 16 pi over 12 and 3 pi over 12. This one is 4 pi over 3. This one is pi over 4, both of which are common arcs. So according to this formula, we have sine of 4 pi over 3 cosine of pi over 4 plus cosine of pi over 3 sine of pi over 4. Now, as far as 4 pi over 3 is concerned, remember the reference arc is pi over 3, which means the same value that you have for pi over 3, all you have to do figure out positive or negative. Now, sine of pi over 3 is the square root of 3 over 2. This, by now, you know it's the quadrant 3 and it's negative. So minus square root of 3 over 2. This is, of course, square root of 2 over 2. Cosine of 4 pi over 3, again, in the third quadrant, cosine is also a negative. Cosine of pi over 3 is positive 1/2. In the third quadrant, negative 1/2, and this is square root of 2 over 2. So all of them, the denominator is 2 times 2, 4. This one is minus square root of 6. This one is minus square root of 2. That's the final answer. Again, understanding the basics that we have discussed and the concept of a reference arc is extremely important, everybody. Find the exact value, cosine of 4d cosine of 80 minus sine 4d sine 80. And if you have memorized those formulas, you see that it's the cosine of alpha plus beta. So take a look at this one and compare to part A. You notice it's cosine of, so we are going this way. So it's cosine of 40 plus 80, which makes it 120 degrees. The reference arc is 60 degrees. Cosine of 60 is 1/2. In the second quadrant, cosine is negative 1/2. So I want to make sure we put all of this together. This means the reference arc, okay, is 60 degrees, okay? So it's the same as cosine of 60 degrees. You have to figure out if it's positive or negative. And in the second quadrant, by now everybody knows, of course, cosine must be negative. Sine 80 cosine Tony minus cosine 80 sine Tony. You should recognize you're dealing with this formula, sine of alpha minus beta. Sine of alpha minus beta, everybody. So what happens? Sine of 80 minus 20, which is sine of 60, and it's a common arc. Square root of 3 over 2. Everybody's comfortable with that. Given sine alpha as 4 over 5, and alpha is between pi over 2 and pi, quadrant 2. And sine beta is negative 2 over square root of 5 or negative 2 square root of 5 over 5. And it's between pi and 3 pi over 2. third quadrant, right? Find the exact value for cosine of alpha, cosine of beta, cosine of alpha plus beta, sine of alpha plus beta. Okay, so let's find cosine alpha and cosine beta. They become simply a piece of cake because we are going to use the identities. We finish those two in no time as long as we find these two values. Starting with the sine, there are two ways to find the cosine. You can go with the circle. Okay, this is 4 over 5. That means y over r. And we are in the second quadrant. Y is 4. R is 5. And we're talking about this one, and x is missing. This is one way. Again, I want to refresh your memory about them. There are two methodologies. So x squared plus y squared is r squared. X squared plus y squared is r squared, which is 25. And x becomes -3. Because it's in the second quadrant, x becomes either 3 or -3, everybody. Since we know it's in the second quadrant, x is negative is -3, okay? And therefore, cosine is solved. Cosine is x over r, which is -3 over 5. Okay, so that's one way to do it. Very straightforward, everybody. If we want to use identities, and many times we may prefer that. Remember, sine squared plus cosine squared is 1. Therefore, you can say cosine alpha is plus minus square root of 1 minus sine squared alpha. I am assuming the following, everybody. When we know sine squared, let's say I'm going to go with x, plus cosine squared x is 1, then we know that sine x is plus minus the square root of 1 minus cosine squared. That's the assumption. So cosine, of course, is plus minus the square root of 1 minus sine squared. So we know all of those. And so when you calculate and finish the job based on the quadrant, you make a decision. So plus minus the square root of 1 minus 4/5 squared. As you know, this is 16 over 25. 1 minus that is 9 over 25. 16 over 25. Let me just write that. So this is 16 over 25. And this thing is 9 over 25. So plus minus 3 over 5. Now, because we know this is the second quadrant, right? We discussed that. In the second quadrant, cosine is negative, so minus 3/5. So you can go this route, you can go this route. You should be familiar with the concept. So we're done with the cosine. We're going to cosine of alpha. We're going to move to cosine of beta. Let me clean up the mess. To go to cosine of beta, we're going to write the information that we have here. And sine is given. We are dealing with the third quadrant. So we're going to write the formula for cosine is plus minus the square root of 1 minus sine square root of beta, and we plug in. Again, I don't want to use both methods now. I just reminded you of both methods here. This one, I'm going to go with the identities, okay? So what happens over here, this becomes positive 4, this becomes 5, 1 minus 4 over 5. So what's underneath is 1 minus 4 over 5 or 1 over 5. And so the square root gives you plus minus 1 over square root of 5. In the third quadrant, cosine is negative. Again, pay attention that it's third quadrant, and that really makes a huge difference. In the third quadrant, we should know what's going on. Cosine is negative, and of course, you can rationalize. Now, if I want to calculate cosine of alpha plus beta, I use cosine alpha cosine beta minus sine alpha sine beta. And I'm going to write the summary of what I found. Sine alpha is 4 over 5. Cosine alpha is -3 over 5 from this column. from this column, sine beta is negative 2 square root of 5 over 5. Cosine beta is minus square root of 5 over 5. Now I'm going to put them into the formula for cosine of alpha plus beta. Cosine alpha cosine beta minus sine alpha sine beta. And when you do the math, let's see what happens. The denominator in both cases, class 5 and 5, the denominator is 25. So what do we have here? We have 3 square root of 5 positive because it's negative and negative. So this, the numerator becomes 3 times square root of 5. This becomes negative and negative positive, 8 square root of 5. So please understand that the numerator would be 3 square root of 5 plus 4 times 2, 8 square root of 5. And the denominator is the product of 5 and 5, 25. And so that's the final answer. Let's do the sign using the sign of alpha plus beta, which is sine alpha cosine beta plus cosine alpha sine beta. Plug in those numbers. That's why this table helps. Quickly use table and plug it in. Again, let's do the math. The denominator is 25 in both cases, so we have no problem. Then let's look at the numerator in both cases. So we have, let me use a different color here. Okay, so 4 times square root of 5, so minus 4, it's negative. Then negative 3 and negative 2 square root of 5, it's positive 6 square root of 5. Just take a look at the numerators, class. This creates negative 4 square root of 5. This creates positive 6 square root of 5. So we have positive 2 square root of 5 in the numerator. The denominator was 25 in the first place. Pretty straightforward, everybody. And we pay attention again to the quadrant. Cosine of power 2 plus theta, we want to prove it's negative sine theta. Well, remember, we start with the more complicated side as always. And in this case, again, the left-hand side will do the job. So we're going to start with that. Cosine of power 2 plus theta is cosine of power 2 cosine theta minus sine power 2 sine theta. So again, pretty straightforward, everybody. And all we have to do, evaluate it. As you know, cosine of power 2 is 0 and sine of power 2 is 1. So plug in. Therefore, this goes away, becomes 0. This becomes negative sine theta, and everybody's happy. We are looking at this example. And again, we start with the left-hand side, everybody. Cosine of pi plus theta is cosine pi cosine theta minus sine pi sine theta, starting with the left-hand side. So what is cosine of pi? Negative 1. What is sine of pi? 0. So this goes to 0. This goes away. This is the answer. Minus cosine theta is your final answer. All right, what about tangent? Tan of alpha plus theta is plus beta is tan of alpha plus tan of beta. over 1 minus tan alpha, tan beta, and tan of alpha minus beta. Basically replace the beta with negative, becomes tan alpha minus tan beta over 1 plus tan alpha tan beta. So we're going to prove the top one. And as you know, tangent is sine over cosine. Tangent is sine over cosine. Let's expand it. Sine of alpha plus beta, put it up at top, sine alpha cosine beta plus cosine alpha sine beta. Cosine of alpha plus beta, put it at the bottom, cosine alpha cosine beta minus sine alpha sine beta. Now we're going to divide the top and the bottom by something to give us what we are looking for. We are looking to find this. So if we divide this by cosine of alpha, cosine of beta, these two cancel each other. Sine alpha over cosine alpha gives us tan alpha. So look at this one. Here's the trick. What do we need to get to tan alpha? Divide this one by what? Cosine alpha, cosine beta. That's exactly what we are going to do. Now we are going to make up 4 fractions. 2 at top, 2 at the bottom. Separate the 2, separate the 2. So what happens? These 2 cancel each other. This is tan of alpha. These 2 cancel each other. Let's do it this way. This is tan of beta. They are identical, the top and the bottom. Everything cancel out, you get 1. This is tan of alpha. This is tan of beta. Believe it or not, that's a proof. Now, to prove this one, and I'm going to leave it for you to do that. To prove this one, all you have to do, the same trick that we used for sine and cosine, everybody. Same trick. So use plus minus beta here. So to prove this one, write this as plus minus beta and put the minus beta instead of beta into this formula, you get the second one. That's the proof, everybody. So you can easily prove that. Tan of 2 pi minus theta equals to minus tan theta. Again, we start with the more complicated side, namely the left-hand side. So what is tan of 2 pi minus theta? We use this formula, tan alpha minus tan beta. So tan of 2 pi minus tan of theta over 1 plus tan of 2 pi tan of theta. So we use this formula. All right, what is tan of 2 pi? 0. So this is 0, this is 0. You end up with minus tan theta. Okay, so let's replace it. You end up with minus tan theta over 1 because this is 0. And that's a proof. That's the right hand side, and that's the proof. Let's move on. And again, we start from the more complicated side, the left-hand side. So we just rewrite the top as cosine of alpha minus beta, which is cosine alpha cosine beta plus sine alpha sine beta. So we start with the more complicated side, namely the left-hand side. And clearly we make up two fractions. So what happens is this one is cotangent alpha. This one is cotangent beta. The top and the bottom are identical, just one. Sine alpha, sine beta, sine alpha, sine beta. And so that is the right-hand side, and that's the proof. Cotangent alpha, cotangent beta plus 1. Again, tan of theta plus pi over 2 equals minus cotangent theta. We are going to start with the more complicated side, namely the left-hand side. We're going to expand that using the tan formula. You're going to expand that using the fact that it's sine over cosine. Sine over cosine. So it's sine of theta plus pi over 2 over cosine of theta plus pi over 2. So we have sine theta cosine pi over 2 plus cosine theta sine pi over 2 in the numerator, cosine theta cosine pi over 2 minus sine theta sine pi over 2. And now we plug in cosine of pi over 2 is 0, so these two are 0. Sine of pi over 2 is 1, these two are 1. So what happens is that this is 0. So this is 0, this is 0, and this is left. Cosine over negative sine, which makes it negative cotangent theta. All right, we want to establish this identity. We start from one side, and in this case, I think it's easy to see that we can start with the left-hand side, write each one and expand it. So the left-hand side, cosine of alpha plus beta goes at top. Cosine of alpha plus beta goes at top. Cosine of alpha minus beta goes at the bottom. Just write the two. So cosine alpha cosine beta minus sine alpha sine beta over cosine alpha cosine beta plus sine alpha sine beta. And to get to this, remember the very first entry is 1. So how do we make this one 1 if we divide by itself again? Here's how you use the trick. You want to get to 1. How do we make this 1 into 1? So these are the tricks that you learn along the way. If I want to change this to 1, I have to divide it by itself. So we're going to divide everything by cosine alpha, cosine beta. When we do that, clearly this becomes 1, this becomes 1, and now this one, let's separate them and see it. Clearly we get to the answer that we want. Practically we are done. But this is 1, this is 1. Everybody can see that. This one we're going to write sine over cosine alpha. This is sine over cosine beta, the same thing here. So we separate them in this fashion. And now clearly this one tan of alpha, this one tan of beta, same thing here tan of alpha, same thing here tan of beta, and that's the right hand side, or HS. Again, the shorthand notation, left hand side, right hand side. Okay, so we prove that, everybody. We want to find the exact value of cosine inverse of 2/3 plus sine inverse of -3/4. It is extremely important to remember the concept of inverse trig functions. They represent an angle, an arc. So this represents some angle, let's say alpha. This represents some other angle, let's say beta. So you're looking at cosine of alpha plus beta, which if you go through the process, you use this formula, cosine of alpha plus beta is cosine alpha, cosine beta minus sine alpha, sine beta. So ultimately, we are going to go here to solve it. But understand, if you set this one equal to alpha, that means cosine of alpha is 2/3. And if you set this one equal to beta, that means sine of beta is -3/4. And remember, in the case of positive, we are in the first quadrant whenever you deal with any inverse trigonometric function. So cosine alpha is 2/3 and alpha is between 0 to power 2. How do we know that? Because this came from the inverse. Remember, the restriction on cosine is the from 0 to pi. Okay, the first quadrant is positive, the second quadrant cosine is negative. So we know for sure this is the case. So again, in order to find this, remember we want cosine of alpha plus beta, which means we want this one, and we want sine and cosine for each angle. For alpha, we have the cosine, we want the sine. For beta, we have the sine, we want the cosine. So we're going to go with sine squared plus cosine squared equals 1. And again, this one sine beta is -3/4. And this is from -power 2 to 0. Here's the reason. If you recall, sine, the restriction is from -power 2 to power 2, the fourth quadrant and the first quadrant. Since this is negative, this is we know it's in the fourth quadrant. When we say from -power 2 to 0, that means quadrant 4. And in quadrant 4, because we want to find cosine of beta, cosine is positive, okay? In quadrant 1, everything is positive. Cosine is positive, so is sine. So sine squared plus cosine squared equals 1. Therefore, sine is plus minus the square root of 1 minus cosine squared. And we know sine is positive because it's in the first quadrant. So 1 minus 2/3 to the second power. This is 4 over 9. 4 over 9. So we get 5 over 9, or the square root of 5 over 3. For this one, we use the same formula. Sine squared plus cosine squared is 1. Cosine is plus minus the square root of 1 minus sine squared, but cosine is positive. Y, again, quadrant 4, okay? So this is obviously 9 over 16. We get 7 over 16, and the square root of that is square root of 7 over square root of 16, which is 4. Now we are ready to answer the question. Cosine of alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Let's plug in. To plug in again, let's give everybody this table. So just plug in. The table helps because you're organizing your work. When we plug in, notice the denominator is 12 here and 12 here. So the denominator is 12. This is 2 square root of 7. This is plus 3 square root of. But the denominator is the same, which is 12, everybody. That doesn't change. Now, this is the exact answer, and you can keep it like that. I'm going to get one more example, a slightly different methodology. We are looking at secant of alpha minus beta, which is secant alpha secant beta over 1 plus tan alpha tan beta. And we start with the left-hand side. Secant is 1 over cosine. So it's 1 over cosine of alpha minus beta. And we're going to expand this. Cosine alpha cosine beta plus sine alpha sine beta. So when you look at this, to change this to secant, secant is 1 over cosine. So you want secant of alpha, you want 1 over cosine of alpha. You want secant of beta, you want 1 over cosine of beta. And therefore, we're going to go from here to here, we are going to divide the top and the bottom. Or maybe you can look at this one. 1. In order to get to 1, you have to divide this one by itself. That's another way of looking at that. That may be even faster. If you look at this, in order to change it to 1, you divide everything by cosine alpha cosine beta. So that's how you see the trick. Now you cut the top into 2 fractions, the bottom into 2 fractions. So look at this one. So what we do, this is 1 over cosine alpha times 1 over cosine beta, and this one 2 fractions. Clearly, this is secant alpha. Secant alpha, secant beta. That's the numerator. This is obviously 1. Tan of alpha, tan of beta. We just proved the identity that secant of alpha minus beta equals secant of alpha secant beta over 1 plus tan alpha tan beta. We started from the left-hand side. We ended up with the right-hand side.